Yeah, I think we are live. Hello, everyone, and welcome all on Data Phoenix webinar. Today with us, Andrei Lopatenko. He have amazing experience work in different companies like Apple, Google, Walmart, and other. And one of core his experience is recommendation system. And today we speak about recommendation system and how LLMs and generative AI can improve these systems and change the game. So I give the microphone to Andrei, and we will um, speak about this topic. If you have the question, don't forget ask them using Slando. The widget is under the video. Also, we have the link to the Slando, and we will answer for all your question in the end of Andrei presentation. So, Andrei, your stage.
Good morning, everyone. Thank you very much, Dmitry, for inviting me. I'm very honored to present here. I am presenting second time. Before I was talking about LLM evaluation, which is another very important topic in generative AI and LLM world. And today I'm talking about how generative AI can provide value to recommender agents. And you're like, it's now, but it's by now it's known it can provide quite immense value by improving quality, creating new experiences within recommender agents. And I will talk a little bit more what exactly mean when I talk about recommender agents, right? Because there are recommenders, there are personalizations, there are search engines, what's their role in industry, and how generative AI provides this value, and what new type of like improvements can be done with generative AI. Why I'm talking about this, I'm in tech after my doctorate degree from the University of Manchester in computer science, 18 years. I started in Google. Early Google, it was 2006. And then I was working in, besides Google, I was working Apple. Then I moved to leadership, led search in Walmart, eBay, Megadon Labs, Zillow, recently Neuron 7. And I have 18 years of experience building search and recommender agents. And recently, of course, applying a lot of generative AI to create new recommender agents or improve existing. And I built very different of them for web, for e-commerce, for local maps, for real estate, for media such as music, video, books, app store. And of course, there are a lot of similarities, but there are a lot of differences. And good to see this landscape, which I can share with you. What makes them generative AI good for those very different types of recommender agents. So what are recommender agents? There are like I believe it's a little bit artificial difference, but there is difference between search and personalization and recommender. I will talk about this. Recommender agents are recommending items to user by analyzing historical like interest of the user, their current interest, and of course they understand deeply items. There is this classical distinction kind of which was used in classical recommender agents about collaborative filtering when you do recommendations based on user behavior, like historical user behavior. You see that users who bought this item, they bought also this item. So if new item buys, if new user buy I, you can recommend them B. Or there are content-based which look deeply into understand these items are similar. So if user interested in one, let's recommend them another. And of course, as a builder of real recommender agent, you don't care about methods, you care about more customer advantage and business advantage. You use all type of modeling, all type of systems which you can do to create better recommendations. And real world recommender agent always used all of them. And basically, kind of coming back from formal point of view, what is recommender agent is a system which has user, like this particular person is buying or shopping or renting, whatever your experience now, you know their past behavior, you know current activity, you know some other context of their work, like for example they are looking for this restaurant now on the map recommendation engine, or they're looking for this hotel at travel recommend agent, or they're looking for this furniture piece on this e-commerce recommend agent. You know some context, their location and so on. You show them other items to help them engage and buy something from your business. Just examples, right? So one of popular recommended agents is Amazon. when you go to item page, they recommend you frequently bought together. So you see those items which are frequently, like I'm looking at certain item right now, and again, we will discuss this later. Recommender agents, not just list of items, there are also explanations so that you understand why this item is good for you, right? And you see like people who bought this item frequently bought together this item. So this is good example of behavior-based, collaborative, filtering-based recommender agent. And the same below, right? Customers also bought or read, but you see like also some explanations such that you can see is it similar books, is it by some publishing house, lingo mastery, vocabulary, slang, word lists, other similar topics. And what you discover building recommender agents, explanations helps really a lot, right? Users want to understand why this item is good for them, not just to see a list of recommended items. Another example of very classical recommender agent is Netflix. So basically, they pick up for you what they believe most relevant for you, and Netflix is kind of one of heroes in recommender community because maybe you remember they had this very big $1 million prize competition, which helped to start a lot of new areas in recommender community and make it really popular in academic. But it's good example, because what now majority of user engagement with Netflix is driven by recommender agent rather than by search. I will talk a little bit later about search versus recommender agents, but some systems more driven by search, recommender helping some opposite, and Netflix is a good example where recommender engine is much more important. And here you can see the same, right? They find best items for you based on your interest, but they also provide explanations. This is today topics for you. This is exciting movies, whatever they mean this, right? But somehow they generate this. This is critically acclaimed movies, and it's very different type of recommendation, right? A very different catalog section, very different type of engagement you expect. And if you want to build good recommender agents, there are some necessary science things which you want to do, right? You need deeply understand item and cross relation between items. You want to understand deeply users. You want to deeply understand context, and depends on a recommender agent. Deeply understand why users engage with items and how, and ability to explain to users why these items match their interest. And what's important about this in context of generative AI is that generative AI significantly can improve modeling in each of these areas. Not just coming with some like generative AI hype, but it's really can help understand item better. It can understand behavior of users better. It can explain better. There are multiple different, if you consider LLM, multiple different capabilities, like encoding of real world knowledge, inference, ability to explain, which creates LLMs and recommender agents really useful for recommender agents. Basically, what goals of recommender system: deliver a list of recommended items to customers that maximize both customer engagement and business value for the company, different related but different goals, and for contextual insights and explanation to guide customers and make informed decision, increasing likelihood of engagement. There are different metrics how you measure performance recommended agents. I'm talking to this to explain what are recommended agents, but also this is what you tune your generative AI models for recommender agents, right? And there are different accuracy metrics, which you typically measure offline. Are these items relevant at all? Do you recall all important items for this item to recommend? Engagement metrics, typically is a kind of more important area. It's like conversion metric, first click metrics, average size of the basket, right? If users visit you and within one session, how many items will they buy? What will be the total cost of these items in average, right? User experience metrics, they're related to engagement, but not one-to-one. Satisfaction, feedback, churn reduction, abandonment at the session level, like people come, they search for something, but they did not find and they left your website. So good metrics to measure, bad results, right? Business impact metrics, how your recommender system totally affects your business, revenue per session, average order value, inventory impact, churn of inventories. There are multiple different diversity novelty metrics. They are quite important frequently for business. You want to encourage people, let's say, buy very different items. You want to encourage users to discover new results which they don't know before, right? So not just recommend them what they buy for certainly, and they know already, help them discover new categories, and then they will start buying new things with this new category. A lot of important longitudinal metrics measuring long-term engagement, retention rate, customer lifetime value, engagement over time, time between engagement, and they typically very dependent on quality. If users come to your system and it recommends them good stuff, right, they will come back with high probability, and it's very important both for customer satisfaction but also for business of your system. And of course, there are system metrics, latencies through output, uptime, extremely important because uh, they're very related both to business and customer experience, and it's really important. And especially with generative AI, where models are really big and require hardware resources, it's easily to do something wrong, like either create a long latency or very high cost of maintaining your recommendation system. And of course, people work a lot of on optimizing stuff there. So those are extremely important. And of course, uptime, right, is another really important metrics. Uh, Frequently, I notice there is kind of in many companies there is a distinction between recommendations, personalization, and search, and frequently this distinction even goes to organization level. You have like search team, and it's very different from recommender teams, right? And I think it's like from my experience, I think it's wrong approach. Of course, you may have them a little bit separate by organizational principles, but they should be really working on the same goals because they solve the same problem. People come to your company website, right? And let's say they want to buy a laptop. It's not important for them. It's not important for you. Did they find this laptop and bought because they search it or because they went to recommendations, right? Their task is not to their task and your task is not to make the best best recommendation or best search. It's serving another task, help people to find what they want. And organizational separation frequently kind of creates a lot of confusion and a lot of wrong metrics. And as one of my important experiences, good to have search engine and recommender systems teams to be as close to each other as possible because goals the same, and frequently also methods the same generative AI models, the same deep item understanding need, the same user understanding need, and having this stack together helps a lot to create much better recommender engines. And of course, business impact bigger. Just kind of like, from my experience in Walmart, eBay, Zillow, recommender agents drive typical kind of everyone likes to talk about search as a big business, but recommender agents typically drive very substantial part of your business revenue also, right? If you look to different reports, let's say Amazon says around 35% of items sold on Amazon coming through recommendations, not through search, but through recommendations. There are very different type of recommendations on item page recommendations, more personalization when you come to the main page, but there are all recommender agents, right? And Amazon search, as you can think, it's very substantial. There are other links. Actually, I did not. There is link below on McKinsey here. 35%. Alibaba says between 10 and 20%. And it's my experience with other systems, typically around, depending on system, 20, 30, 40% of your revenue is driven by recommender agent versus remaining part for the search, right? And it's very substantial for the business. That's why, if you improve your recommender system by 5%, it's very substantial gain for your business and for your customers. And typically, if you did not exist recommender agent, because of it can drive so big time of revenue, they have very high return on investment, and the same any improvements in recommender systems have huge impact on your whole revenue, and that's why it's so important to improve them. So questions about generative AI, right? Can generative AI improve quality of recommender systems, quality of what you do for your customers, impact on your business, customer success? And what I see is there are certainly kind of two different lines. And in my talk about generative AI for search, I see the same, right? There are kind of, can you improve conversion rates, value of your recommender agent within existing framework, right? So you basically, let's say people come to your website, they see item, you recommend similar items, right? What you can do, you can build better ranking model, better recommendation model within the same experience, because you understand customers through better sequential modeling of their behavior, which is one part of generative AI when you use transformer architectures for sequential modeling. Because you better understand items, and there are multiple different things what you can do there, right? Embedding generation do a lot of. So when you take text of item, and also actually you can use behavioral data, there are many different things you can do. Knowledge graph representation of your catalog and transform into embedding representation. You can do, I will talk about that later, much better information extraction from text about item. You can now like very easily do image understanding. Let's say for many items would be e-commerce, real estate, travel, food. There are a lot of images, right? You can do much better image understanding now and have much deeper item understanding, and then basically based on this create much better recommendation within the same framework. You maybe customers will not see any change, but they will have 10% or 20% high engagement just because you recommend better items, or show actually not just recommend better items, show more explanation, but it's within the same framework what exists now. Another framework where generative AI can improve recommender agent is through new experiences. For example, multimodal recommendations become really easy now comparing to what before. Can you recommend items which are similar to this one visually? And it's important, like if you buy furniture or if you look for a house and you like really this interior or exterior, find me similar houses. Many other multimodal recommendations become much more easier. A conversational experience. Can you create agent, kind of an AI agent, which will be talking to person as a very knowledgeable expert and help them to select the best camera, best laptop? Yes, you can do it now. New type of recommendations, explanations, voice experiences. So generative AI make possible for many companies create really good experiences now, and it's also much more easy. Like you don't need huge team now. It's pretty easy to create such things. Typical problem, again, kind of coming back, of recommender agents, which generative AI helps to solve within multiple paradigms. Cold start of items, right? So typically, like once you have a lot of data about how people interact with this item, relatively easy to build good recommendations. Assume you have new item, I have nothing about this. Can you transfer knowledge what you have previously to this new item? So cold start problem for item. Cold start problem for users. You have a new user. You don't know what this person like, but there is some kind of preliminary information, cohort of user. Can you create cold start problem for users? And then generally, as customer, like one is new user, but users don't interact much. I mean, they interact much, but there are different interactions. Some don't interact much. How you can make this really good recommendations when you don't have much data for this particular user? Explainability. Given a set of items you want to recommend, how to explain to user why these items are good for you. And you see it's very prominent now. Like if you look Amazon 10 years ago, it was just list of items. Now they put a lot of explanations, the same Netflix, the same what we've done in other companies. Explanations really important for recommend agents. Contextual modeling, how to model all generic knowledge about domain. Multimodal data understanding, how to use images or videos where you have about items and create, use them in recommender. Complexity of customer interests. Typically, as you imagine, a user interacts a lot with your system, and you see they have interest in very different types of catalog. How to build good recommendations based, you don't want to recommend them everything for every session, right? How to understand current context and mix it with global context. Time trends, user interests evolve over time, whole domain evolve over time, right? You can imagine, let's say, shopping. What clothes people buy in summer very different from winter. How you can model this inside your recommender system and recommend best items now. The same about books, the same about everything. Multi-target optimizations. There are multiple typically business targets for your optimization function, how you can make this. And then you want to scale, right? So there are a lot of this kind of more science engineering problems of recommender systems. There is it's very interesting for me. I work both in search and recommender agent. I see a lot of development, and as you know, like in public, it gets a lot of hype about search in generative AI, right? Like Perplexity, U.com, launches by Bing, Google, everyone talks about about search and recommender agents. But if you look into number of publications, you see many more publications in academic community about recommender agents. What more important, they're much more diverse. They go for very different tasks. And certainly you see much bigger potential impact of recommender agents into generative AI into recommender agents. And again, like coming back, they take recommender agents produce huge revenue, so the same business impact. I wonder why public is not so interested, tech media not so interested in this. Perhaps because it's more technically involved. Like everyone can talk about and just perplexity. If you cardinally improve recommender system on some website, it's not so obvious. It's big business impact, big customer impact, but not something you come and play with. Maybe it's one of the reasons. But there are several, like you see, like publications I share on the right here, a very big set of articles about different tasks. This is another good article which gives you a review what's going on with generative AI and recommender system. I recommend to read this 3 article, previous this one and next one, and you see there are a lot of different developments. On the line above is more like, so like it was line A. It was like, maybe you remember, like 2016, 2017. It was this wide and deep neural modeling for recommender system from Google, which produced a lot of impact in industry through deeper modeling techniques, better ranking techniques for recommender agents. And there were a set of articles how to use deep networks for recommenders. And then it was like 2 different developments. One, B and D, is more like conversational recommender systems, where we talk new experiences, how you can create better conversations, recommender agents acting as conversational agents. Big one, right? Going below is more like about modeling techniques, like behavior, behavior modeling, other when you use LLMs or transformer networks in general to model behavior. And now they're converging such that you can do both of them. And of course, there are many new results, really important. And also, like LLM agents architectures provide a lot of value. And then another, sorry, it's small script. I just want to show here diversity, right? You can go, this also really good article review exploring the impact of LLMs on recommender system. And as you see, there are many different areas, right? There are conversational systems, there are sequential behavior modeling, very different types of applications of LLM, cardinally different, where they provide huge value, and there are even more. We'll talk about this later. So let's kind of do a little bit deep dive into several. Again, to cover this, we would need perhaps 10-hour class, but let's do just a little bit deep dive into some areas which I believe important. Sequential recommendations, they're core of almost any recommender system, right? Because historical user behavior is very important signal, very important feature for your recommendations. Recommend your items for users, and then you want to recommend best items for this particular user. And basically, the problem having a historical user behavior on your website or app, such as click, buys, browse, event searches, understand this user and recommend what next item we can recommend for you, right? There are different things. Like there are long-term behavior recommendations. When you observe user for several months, you get kind of their key interest and you want to recommend based on this. In this talk, we will talk more about short-term session recommendations. When you observe behavior of user within like current session, and session means typically current non-interrupting behavior on your website. You put some, like, let's say, if user out of my website or my app for 1 hour or 15 minutes, depending on this, it's break session. Let's look into current session. So what they do right now. And sequential recommendation is one of the important topics in recommendation systems, both classical and new. And like what was really interesting, like transformers, attention architectures, almost immediately since they were proven for language problems, they started applying them to recommender systems. There is Yoli Paper SAS-Rec, BERT4Rec, like 2018, 2019, because like language is, it's very similar. Like what is language? It's naturally sequential problem, right? What user behavior is naturally sequential problem. And then modeling techniques such as transformer, applying both of them with the same advantage. And so again, like basically, it was immediately proven such that transformer-based architectures, which I put into LLM space, not necessarily, not all transformer architectures are LLM, but they kind of from the same space of deep modeling techniques. Leveraging self-attention for user item interactions. What I good about, like, as you model this with classical methods, different time series method, different methods based on RNN, it's very hard to catch long-term behavior within your session. And transformers allow this. And they also allow to handle variable length sequences. There are many other advantages why transformers proved really good for sequential recommendations. Again, there are several popular models. We will talk a little bit more about transformer 4Rec. It's a model from NVIDIA. And again, what's the goal of transformer modeling for sequential recommendations is recommend items within a single user session. Not looking to long-term user history, but more like single sessions. You care about short-term user preferences. What good about such models like Transformer 4Rec, you can put multiple input features inside the easily model, easily, not just like atomic click events, but put a lot of features about what happens inside, what items are click, what features of those items to model to predict next. A seamless feature engineering. This I'm talking now also, I did not put on slide about transformer for React, this framework for NVIDIA. It's a bit old, 2021, but actually proved very valuable for many systems and very easy to use because it's not just some science paper, very good library, well integrated with NVIDIA set of tools to serve models with feature engineering tools and so on. Transformer helps at treating each session as separate segments, positional encodings to capture order within sessions. So transformer architecture proves super valuable for this. And also, again, it's very hard to identify important items. Self-annotation helps this. So there are a lot of advantages of transformer type-based modeling techniques. And we will talk about transformer for React. But there are actually many. If you look recently, there are many papers, academic papers, which explore very different transformer-based adaptations. There is recent paper using LoRa framework, which provides a lot of so it's very active area with a lot of advantages, which you can certainly use for your system, right? There are several key components from transformers which really help here. I'm kind of giving high-level architecture from transformer for React repository, how it works, and so on. But there is also kind of such that you can tune loss functions. There are multiple different tunings which you can do and use better transformer for React for your system, for your modeling. And actively used in industry, transformer for React, compatible with PyTorch. They also claim they're compatible with TensorFlow stack, but I did not check that much, did not work much with that. Easily to integrate with your custom features, work with Tabular. It's another great library from NVIDIA for feature engineering. It won multiple recommender system context, and what really good, if you go by this article, there are a lot of explanation from teams how they did it, which you can apply to your system, right? How you can do really good behavior modeling, sequential modeling for my system using this library. There are multiple applications why this is good, right? Next item prediction and sequential recommendation, session-based recommendations. Like for ranking tasks, it can handle complex feature interactions for improved ranking, predicts your CTR rate, easily to transform to new domains, and it's very typical for a very important need for many recommender system, cold start problem integration, and so on. Outperforms many traditional methods in recommender systems, which are still used and driving very big part of the industry. So transforming for React for this like sequential recommendations proved to work better. Many deep learning approaches outperform, and again, competitive with those old methods. And again, there are many new methods. So this area is continuously developing, but most of this academic paper, while transformers for React is really good, well-written library, easy to adopt, easy to use in like industrial settings, high performance serving with NVIDIA Triton, and so on. Another very different approach, LLM rank, right? It's more academic paper, but is this for like kind of the way you use LLM? So this more not like a transformer for React is not LLM per se, but more like transformer attention-based methods, proven, and of course there is a lot of flexibility how to use them and a lot of new methods being developed. LLM rank is more like how to use ready LLM and to build recommendations for you. And what is it good for? It does not provide kind of, assume you have a high developed system. It does not the best ranking function, but it allows you to develop new recommender system as very fast, very soon. It has certain advantages. It's not the best ranker kind of overall, but it has certain advantages, kind of cold start of recommender engine. And I know several industrial use of this similar framework, right? You don't need to copy what they're doing or library what they don't have, but they have, but kind of like approach is really useful and really working well for some frameworks, for some needs of recommender systems. So basically it works as zero-shot ranker, big advantage for some purposes, right? And so basically, of course, it does not create everything for you. You need to create recommended items, kind of, you need to retrieve your set of candidate items, which frequently more easy, right? Like you have separate task in the recommender system, retrieval, ranking, right? And sometimes ranking a bit more easy because you kind of understand at high level what user wants, you can retrieve all of these items, but then how to find out of them the most relevant. Recommendations are conditioned on user history, previous interactions with items, and of course there are like coming back. There are significantly better rankings than LLM rank, but over here task is zero-shot ranker, which very like says that basically you can do zero-shot recommendations, and it's very important for some time when you deploy, especially new system, how you want to do this. Again, I have links to all original papers, right? And kind of high level work of this, and like how they propose and what they improved. They use, so basically what you want to do with this LLM rank, you get like you have a sequence of previous user interactions which you encode into text, right? Because you feed it to LLM. Like my user browsed, my user watched this movie, and this movie, or user watched this movie, check this movie, but did not like this, and so on, right? Or the same for your e-commerce items. So you have text all encoded like interactions of users. You have set of generate items, and then you rank LLM, tell me taking this history of this user, what would be the best recommendations. And LLM solves for you sort of tasks. That's kind of, it's easy to build from the first step, but there are several problems, right? Like maybe here explanation, right? So sequential prompting. They found LLM not like when you feed user past behavior to LLM is not really good in understanding like sequential time, right? It understands a set of mixed items such that user watch this, and this, but does not understand well and takes into ranking that user watch this after this one, right? And there are several things they propose here, right? And what improve? First, you do sequential prompting, as and describe all items in sequence, but then you emphasize to LLM. Most recently, user watch this one, right? And another what they found improve also in context learning when you give your LLM some previous interactions, what you for like user who like X, A, B, like D, and so on, right? This helps also. Sorry, previous one helps user also to make better recommendations. What they found also when you give a set of candidate items to LLM, it's as sensitive to order of them, right? So you assume when you retrieve items for as a candidate, you don't know the real order. But they found when you feed to LLM, because LLM is a language and it's sensitive to the order, it creates some barrier on based on the bias based on the order. And for this, they use bootstrap technique. Basically, they create multiple different parallel execution and then randomly reorder candidate items. And then they ask LLM to generate them for multiple different bootstrap sequence of candidate items. You can see more details in the paper. This kind of high-level description what they're doing. And basically what they did, they like with them, you want to have for retrieval service, you want to limited set of items up to 20 they found. These items are sequentially encoded into prompt for ranking, and ranking for ranking task is formatted according to the ranking template. And you can find more details in the paper. And it's easily like you don't need to necessarily use the framework exactly, but I think principle here very easy to use to create. And again, I know several examples. I did not ask people if I can talk about details, but several, and also my experience, several examples in big industrial settings where similar approach works very well, especially when you want to transfer, start recommending in some set of items which you don't know before. You don't have good ranking, you don't have user behavior for that set. You want to build like zero shot, very fast recommender system, really good bootstrap. Another advantage of LLM rank for some systems, because LLM encodes a lot of real-world knowledge which your recommender model may not have. Like, for example, if you build LLM rank, let's say you want to recommend people restaurants to go, right? Or places to travel for tourism, or e-commerce website. You're very dependent on common knowledge, you might like, which your system may not necessarily know, right? A lot of knowledge about real world, about geographic locations, about like e-commerce items, like let's say Canon lens camera is very compatible with Canon camera. So Canon lenses compatible with. And there are many different things how items are connected, which are encoded in some text somewhere, which LLM can learn and use, or the same for movies. And to use this knowledge to better recommendations, right? And LLM ranks allow you to use this common world knowledge to amplify and make better recommendations for you. They did a lot of like it's from the paper performance comparison. So here you see kind of like full behavior based like SaaS React systems, right? Versus zero shot based systems. And what you see is certainly like like this is last three rows are about LLM rank, right? And what you see, certainly, if you compare them to full-based systems like SAS, REC, and other on the top, you see certainly numbers in the first row, in the three rows below, typically underperform to full RECs, to full systems, but they outperform all zero-shot systems, right? So again, then zero-shot rankers based on LLM are not best rankers, but they're best, like not necessarily best, but they're very good zero-shot rankers, right? And there are many industrial settings where you cannot immediately build full ranking system just because of lack of data, because of new domain, and so on. And there where you can leverage zero-shot ranker. And again, actually, from my experience, hybrid systems always provides advantages. You can build really good behavioral based, but then you can elevate also generic word knowledge using type of LLM based approach, providing both of them, or one of them can generate recommendations, but another can explain recommendations and so on, right? It's kind of pretty useful to use hybrid systems. Again, there are several negative features they found, and I found it's the same when you work whenever with different LLM-based approaches. They may be different, but it's important to understand strengths of LLM, but also weaknesses of LLM. For example, for LLM for rank, they found ranking is low, sensitive to orders of items in history. What they do, there are prompting mitigation techniques, and it works in many other settings. You don't need to fine-tune necessarily. There are some actually reports about fine-tuning LLMs for recommenders. But in this case, prompting techniques work quite well. Sensitivity to order of candidates, opposite, mitigates through bootstrapping, right? So some techniques you not necessarily can mitigate through prompting, but through other statistical techniques like running several LLMs in parallel, several inferences in parallel with bootstrap order, right? And like what they found, you need also to experiment, like not just make deploy something and see it works. You need to experiment how long history I have to feed. Like like LLM, we understand them, but they're also black box, right? And frequently you don't understand, like let's say I'm feeding 10 item history, 20, 30, 40 item history to my LLM. Will it perform better with more data? Not true, because it can be confused, because there are many other things with LLM, right? You need a lot of experimentation. I think, and from this paper is good example. There are problems when you apply LLM for recommenders. Some of them can be solved through prompting, some of them through different statistical techniques. Some of them you really need to go more experimentation, understand how LLM runs for this particular recommendations. And again, my experience, I see a lot of, besides LLM rank, as I use in the paper, there are possible extensions which are directly applicable, right? It's not necessary ask LLM to recommend a particular item. You can ask, recommend me category. If people, I see a person browsing for cameras, right? What other categories, like maybe not necessarily particular items, what other categories we can recommend to this user? It can be, let's say, lenses, it can be tripods, it can be bags for cameras, whatever. There are many different, right? And LLM actually quite good if you experiment with this, works quite well. And then you can mitigate different experimentation, different recommender systems inside, not just mix, for example, but create categories of recommendations to expand user experience, and it works also well. Conditional recommendations on tailored, right? Recommendations you can fit an LLM can, under some, not always, under some settings. I have this set of sequential behavior of user, but I know about this user something else. Like, let's say this user prefer this type of movies. Can you recommend something? And LLM will take this context into account. Not always, but like it depends what data trend, and there are many other parameters, but potentially it works quite well. And again, explanations. Explain why did you recommend each of these items. Well, like, and based on this, you can create different better experiences for users. Other tasks. So, as you remember, here, like several slides before, we discussed, like there are very big, this kind of core LLM applications, core task, like better ranking function, better user understanding, task-oriented user interactions, many other, how LLM can benefit really big weight. And there are, this one we have conversational versus core modeling. And these tasks, there are many different ways how LLMs, generative AI benefit to recommender systems. And some other tasks which are not less important. They're really kind of like some of them kind of intersect with those tasks before, but they're really also important. One second. Yeah, so there are many additional tasks, right? Before, like what we discussed, to create better recommendations, you need better item understanding, better user understanding, better context understanding, better ranking function. Those kind of core recommender system tasks. But a recommender system complex things, and there are many other stuff which are needed, which are very, if you build them, they can improve your quality of recommendation quite a lot, quite substantially. And LLM, generative AI, can help there a lot. For example, very big task for your recommender agent understanding what items are spam, right, or malicious intent, that are fraudulent behavior. Depends on your recommender system, right? Like you may recommend, like like let's say, this person like Japanese restaurants, visit this one, and we have a good Japanese not good. We have some Japanese restaurant recommendation or similar in that area which person visits now. But actually, looking into page of this restaurant, we can understand something. Quality is not good enough to recommend. There are many different things, right? Depending on your system. Like, for example, for e-commerce, there are a lot of happens abuse when people want to spam, or like there are different, like there are a lot of depending on domain, many wrong things happens. And LLM can work quite well to detect those wrong things about items, right? From one point, it's item understanding, but it's not contextual kind of understanding of item, more like quality. And there are a few papers published about this. There is a lot of papers about LLM for spam detection in email, but many similar methods work well for other type of detection, right? And LLM proved very valuable in understanding like both like items, also sellers. So kind of like typically in e-commerce system, if you have marketplace items, there may be item, but actually there is a merchant who sells this, right? Understanding wrong behaviors. So like classification of items such that you understand you don't want to, or maybe opposite. Sometimes this item is very high quality. Can you understand this to better recommendation, right? Because typical recommendation quality is kind of mixture of topicality and quality, right? There are different things. So LLMs proved already a lot of value, and not only LLMs, but kind of deep learning methods, including transformer architectures, but LLMs also for item classification, but also like as a generative AI, image understanding, image classification can be very useful for some type of understanding different malicious intent and so on. Catalog understanding, right? One thing you kind of many recommender papers assume catalog sort of flat, but in real world, of course, like items are categorized, they are different. Like what this item is, it's a, let's say, a lens, which is part of photography, which is part of equipment, electronics, and so on, right? A lot of relationship. This lens is compatible with this camera. This restaurant is close to this hotel, right? There are relationship between item, and LLM I really proved a lot of value once you feed item full text description. First, you can create, of course, create embedding representations, those different type of LLMs, but also all sort of information extraction for deep understanding of items, but also understanding of images. I will talk a little bit later about that. LLMs really useful, right? And building relation and catalog, you want to describe whole catalog, and there are typically catalog very complex things. There are multiple, like the same item can be, let's say, iPhone, but from an like as a iPhone, but from another can be a good gift for, let's say, for Christmas, right? There are multiple dimensions what make catalog, and I'm quite good in understanding those and building those relationship. And there is a lot of work because it's really important, very useful about using LLMs to build a hierarchical classification of items, to build connection between items, build knowledge graph, and all of them very useful for building recommender system. Again, data quality and validation, right? When you discover what data provided, especially in marketplaces or like any other such that your company does not own all space, or like restaurants, like text is written by restaurant owners, or you scrap it from their website, right? Understanding data quality of those, because if you have a low quality data, it goes to low quality recommendations, right? Understanding data quality issues, fixing them, validating them is another important application of LLM to recommender system. Coming back, multimodal recommendation where LLM is really good. I want to emphasize there are very different type of images, right? And that's why there is a lot of complexity. Some images can be poor, like just visual, and then you want to find similar items, right? Some images can have a lot of text, like look image on the right, which about dimensions of these items, and you can extract this information and use for other type of recommendations, right? Again, there are very different type of images. Some of them about visual appeal. Some of them has a very useful information, which can be used both for recommendation and explanation of recommendations based on this understanding of text, right? And there are many different models. It's very big variety of models how to do image understanding, like some of them from 2021, some of them more recent, right? Like converting images to text, kind of object extraction from images, super useful for some tasks. Image embedding representation, how to create embedding representation of the image, super useful for other tasks, and there is a lot of intersection, but there are a lot of different product opportunities. So there are a lot of, like, of course, if you deal with geospatial, like when you deal with geospatial data, like local business recommendation, travel, understanding of geospatial images can be super useful, and then you produce a lot of data which can be very useful for your recommender data, like this hotel in this close to the beach, right? You can understand this and recommend this based on this. So there are a lot of good information extraction from like generic models, embedding models, but also more specialized models. Again, now with many other modalities become accessible, right? Like for example, I know like for e-commerce there are a lot of videos about particular items, and you can do a lot of useful information extraction from those videos and audio text related to them to build better recommendation system, because you have better data, but you can have a better experience. You like people like, and it's really useful. Easy to build now. I built before image to image recommendation system for some domain where visual appeal like jewelry or furniture or house really important to understand similarity. Now it's much more easy with generative AI to build the similarity, and you can understand what really type of similarity you want to build and tune. And of course now new interfaces such as voice and image, like build transcription system. Now you can build like surprisingly high quality transcriptions very easily with generative AI models. Like there is this model from Facebook, Whisper, very easy to run on very small machine. You can build very good experiences. So sometimes of course you can buy also transcription from Google, Apple, but you can build really good recommendation just using these new interfaces, right? Another what I found task I was working with, and I know a lot of work coming with it. Like a lot of recommendation system use data provided by people, humans, right? Let's say restaurants, like they write data about them, or merchant for e-commerce, and frequently this data are not good, right? Just because like their main job is to sell the item, not to write description on your website or something, right? And Copilot helping these people to write better descriptions, right? You can understand images of the items they provided. You can understand other text. You can understand generic world knowledge scrapped from the web, encoded in your LLM, and provide them copilots, which helps them to create much better descriptions. And my experience, again, not this whole one, but what I saw, like in big companies like Walmart, item sales very dependent on quality of description, right? Like because as a customer you can find item, but you don't really understand much about this item text. Quality of item text can drive sales very significantly, and this very big opportunity for recommender system, because it's not just direct ranking function, it's something else, but actually like when you build a recommender system you care about end-to-end performance. Summarization, better item pages, another big one. Items has a lot of reviews, right? For example, many websites and applications. Can you create really good description out of these reviews, such that not just summarize them, but provides super valuable what drives, and building recommender system, you understand what drives customer engagement, what descriptions really help customers to make better, more informed decision. Is this item good or not for them, right? And LLM is quite good in this type of summarization task when you have multiple deep focus, multiple deep things, but you want to focus on some particular aspect which makes this item either good or bad or distinguished from others. There are many different aspects relevant for maybe dependent on your recommendation session based within this customer experience. You understand people care about this one, right? Can you build summary by focused on this? And LLM provide a lot of like really good functionality now. It requires a lot of work to make it well, but works really well. And there are some papers about this. And another like conversational recommender system, right? Another very big, very strong topics, because this is what you want to build frequently. Like how someone looking for a house would like to have experience, and kind of what perfect experience. Perfect experience is understandable human agent which can talk to you, understand your interest from different like what your lifestyle, what do you care, what's really important for you, what you can pay for, right? And built on this, based on this, build recommendations. The same thing about travel, right? What your conditions, with whom you're traveling, what are you looking for, what type of entertainment do you like many other questions, and then based on this, build your recommendations. Conversational recommendation, like videos, books, the same, everything based, like you can build a lot of deep good recommendations, but through conversations. And there are a lot of ways. What makes real conversations, not necessarily typing, not necessarily talking, sometimes interactive through clicks, but it's kind of interactive way, so also conversation. A lot of work there. And basically, this is my high-level review how recommender system can act and benefit from generative AI and LLM development. So please, thank you very much for listening. Questions.
Yeah, Andres, thank you for this amazing overview of using LLMs and generative AI in this recommendation space and e-commerce space, because a lot of examples was about e-commerce and so we have some questions. Most of them related to will we publish this presentation and share the articles. Yeah, we will share the presentations also. I think we can prepare some list of links for useful materials. I have one questions for now. Maybe we will find more interesting. Uh, what about tools? We speak about different use cases. We speak about good articles, but what tools you can recommend to use? Maybe you have some stack of some tools which you use for building a recommendation system together with some LLMs.
Yeah, it's good question. Like there are tools like what I discussed, libraries, transformer for React, right? As one, what I really like about this is a ready tool, right? uh, this is tool is like, I mean, it's a production and like a focused ready tool, right? Of course, Hugging Face transformers, I'm talking about, there are many of those basic libraries. LLM evaluation, like one actually it perhaps should deserve separate 1 hour of talk how to evaluate your LLM systems, especially within recommender system. So kind of let's go step by step. Certainly basic tools like Hugging Face transformers, right? One of core blocks which you use a lot in your system, because you will have multiple different use of LLMs, multiple different models, and so on. Sequence transformers, another important library which you will use a lot for understanding text, building similarity on text. Sequence transformers is another library, super important, super useful. Transformer for again, I know people build new their methods, but it's like very good industrial used industrial like kind of not academic libraries. There are a lot of academic libraries which you have to deal with a lot of bugs. Very well tool from NVIDIA, well compatible with other NVIDIA stack, right? I did not work much with NVIDIA stack per se in building production systems. I experimented, and I know like kind of if you talk about tools, NVIDIA have a very set good select Triton server, so on, to building your production environment, but there are many other alternatives. But just coming back, once you build, this is what you can consider as a tools. Evaluation. LLM evaluation is really important, a big part, like once you start building this system. And of course, it's like not just standard, you want to understand how good this embedding. So like there are multiple different tasks within evaluation. And there is this, I have no good memory for names. A good set, for evaluation, from this research community. I recommended this in my LLM evaluation talk. Sorry, I don't remember right now like name. I use it a lot. They have this good evaluation library which is used almost by everyone now evaluating LLMs. What's the name? So it's not open. It's like this research community, and they created this evaluation library, and we see like Hugging Face using them to run all their leaderboards, right? Sorry, I have really bad memory for strings, including names. And very popular tool for evaluation. So those kind of key tools, right? What you want. There are there are not so many. For example, I used some time ago, not recently, building conversational experience, in particular also for recommendations. Rasa was quite good library, but I'm not experienced with this for last 2 years. I don't know, do they catch up with LLM? It was really good tool, really good team. Most probably like for conversational experiences is still good, but I cannot provide you experience with them like for last year. So there are those multiple different tools which you can use to build your recommender agents based on LLM. And then of course you need powerful retriever, a very powerful you want to retrieve set of items. Typically you have some retrieval system under that, such that it will like your LLM will build on top of this, and you can use like different classical like other elastic. Some people use it. Open search pretty good because they have a lot of embedding based, or you can, depending on your system, like use face from Facebook is good library, but not really distributed kind of. There are multiple different things to build retrieval layers for your LLM, for your recommender systems, and then you can build on top of them.
Yeah, we have good, very interesting question about how do you manage business logic and algorithm outcomes. Uh, Very often, business people know what exactly context should be displayed and how they manage what uh, algorithms show and what business want to see there.
From my experience, and I found, and of course, like business frequently driven by very different metrics, and all of them very important for business, right? Kind of you typically talk about, yes, we want to have revenue, we want to have average size basket, but there's kind of high level metrics that don't cover all business needs. Like maybe business needs can be very different. Like we want to have a high churn for new items, we want to have a high discovery for new items we bring to users, we want to have a cross-category selling, right? Such that I will be very diverse. Not just people come and buy everything from this; they buy from different categories. We want to enable our customers to discover new items of our catalog, which they don't see. We want to have, once we have sales, we want to cut. Like there are many different business objectives. What I found is super important talking to business teams to come to common agreement such that you really understand what they do, kind of use them as a main, because they're driving the business, right? Tech making it better. But then transform the business objective into really good numerical representation and agree about them, right? So I found sometimes people optimize something recommender system, but it's not what business want, and they misunderstood, right? If they say, okay, we want to improve discovery of new items by users, it's really important working with business directly. Agree, what does it mean discovering new items? Is it how many new items are sold? Is it how many users bought new items? Is it number of cross sales? There are many different metrics you can imagine to measure the same business objective. What I found really important, talking to the business, come to agreement. Yes, your business objective we represent through this particular goal for our like customer behavior on our website or app or something else, right? And then based on this, you can really easily inform business about your progress, what you're doing, how well you're doing. Also, it helps you to tune your system for that. So what I found is more like communication problem and agreement problem, alignment, not even agreement, alignment. Understand what business, like use business as a ground truth, but also help them. Sometimes they have kind of high level, but not really numerical. Create numerical, clear goal to measure them, tune your system for this, and clearly communicate to business as they understand what progress you're doing, how is it going on, are they happy about this, not. So this alignment I find is really critical about precise measurement, how you measure business goal.
Yeah. One of the problem of as I see, of using LLMs sometimes can be latency because not very often LLMs can answer very quickly. But recommender system work on milliseconds, and LLMs work on the seconds very often. Yeah, how to solve this problem?
Yeah, no, it's a really good point, right? Because yes, you're true. Like especially big LLMs, which like like speed of LLM, of course, very dependent on number of parameters, and like typically if you consider sub-billion parameters, perhaps they're not called LLM, but many transformer-based techniques we discuss here, they're quite small, they're super fast. When you go to 7, 10, 14, 6, like that space up to 20 billion parameters, you get longer delay. Of course, if you go to 70 billion parameters, right, you have even much longer delay. And for this, there are multiple tricks. One of LLM level, how to make LLM faster. Some of them system level, like for example, on item page recommendations, right? You can build whole item page, deliver it, like render it to user immediately. And while meantime LLM behind can have 2 second delay, right? Then you render this page after that. So user have good experience. They see item page immediately and they spend several seconds looking image of the item. And when they come to your recommender page, they will be this will be already rendered, right? There are system level techniques, so kind of there are multiple different, right? But there are also like don't neglect them. You can do a lot of improvements without directly improving LLM, but through system techniques and still make better experience for users, make them happy and make them buy stuff. But of course, LLM based techniques is also how to make improvement. There is a lot of work how to do the same with small LLMs through these different techniques, right? And it's based. So typically, many of these recommended tasks, what we discussed, like summarization, uh, like like other, can be done through relatively small LLMs. You need really big LLMs when you go to conversational tasks. Those, of course, much harder, right? But many of these tasks can be done with much smaller LLMs, like again, kind of Llama, Mistral family, in around 10 billion parameters, which has reasonably good latency. Of course, also working different. There are a lot of like many other on top of LLM techniques like caching techniques, which can help a lot in many cases, right? So I would say like important to consider latency problems as end to end, right? You can do a lot of through beta rendering of the page while LLM thinking. You can render all other stuff, make user having good experience, and LLM will in 2 seconds will provide something better. A lot of on top of LLM like system techniques, but direct on top of LLM like caching and other. But a lot of LLM techniques, can you do the same task with smaller LLM? Multiple techniques, right? Can you do a lot of your system hardware optimization to do it better? Another type of techniques. And people frequently make mistakes also at that level. So like multiple different optimization techniques at every level are important.
Yeah, I agree with this. And how you see the future of recommendation system? What will be next improvement, and what maybe next technology will come to recommendation system?
Certainly, I see multimodal recommendation as quality becomes really much better than it was before, getting much more prominence, right? Whenever you want to buy something, understanding this deeply from images, there are a lot of items, like local e-commerce, travel, real estate, many other, where image like multimodal really important. And then understanding videos, understanding audios gives you much more. Explanation, I believe, is one of the big, like you're like, I like this movie. What other movies you recommend and why? I like this item. What other items you recommend and why? Explanations, I think, will drive a lot of conversion, a lot of utility functional LM. And conversational LMs, I believe, also will be really important, right? You want to travel to Maui, you have your what your hobbies, what your preference, food preference, what your financial situation, talking to you and building very customized for you, very personalized for you recommendations through this exploration of your needs. LLM can provide a lot of value. So there are multiple besides like common, like what we discussed, deep item understanding from images, kind of where LLM make better for you, but kind of inside, not directly visible. A lot of improvements there, just quality of recommendations, but a lot of new experiences will come through LLM, which significantly improve your customer experience and a lot of value to the business.
Yeah. Thank you. Thank you for today presentation and today webinar. Thank you for all who was with us. We will publish all materials in our Discord channel and on our website as well. Thank you again and see you on the next webinars.
Thank you very much. Thank you, everyone.